Whole numbers. In our day-to-day life, to count things, we use numbers like 1, 2, 3, 4. The collection of these kind of numbers like 1, 2, 3, 4 and so on, we call this collection of numbers as natural numbers. And we represent the set of natural numbers with the letter n. So n is natural numbers 1, 2, 3, 4 and so on. So every natural number has a successor. See, for example, 3, it has got a successor 4. If you see 2, it has got a successor 3. And in the same way, the natural numbers except 1, other natural numbers, they have a predecessor. 3 is having 2 as a predecessor and 4 is having 3. But whereas 1 is having a successor, but it is not having a predecessor number. Now, if we add 0 to the collection of natural numbers, this is a collection of natural numbers. If we add 0 to the collection, we call this set the natural numbers and 0. With 0, we call it as whole numbers and we denote it with the letter W. So this is a set of whole numbers 0, 1, 2, 3, 4, so on. So whole numbers or the set of natural numbers with 0, including 0, we call it as whole numbers. So in this chapter, we are going to learn about these whole numbers. Representation of whole numbers on number line. So first, let us see how to draw a number line. Now first draw a line and mark a point as 0 on the line. Now mark some points with equal distances onto the right side of the line. Keep on marking till the end of the line. So we mark as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on till nth number. So this is the number line we have made. So now we observe the number line. Here every number on this number line has got a successor towards its right side. So 6 is having its successor on right side, that is 7th. In the same way, every number is having its predecessor on its left side. So this is a number line drawn with whole numbers. Now we will see the addition of numbers on number line. So here we are going to add some whole numbers using a number line. Here the addition given is 2 plus 3. So how to do this using a number line? The first digit is 2. So let us start at 2. Go to the number line and begin from 2 plus 3. So that is, you have to move 3 positions. Now on which direction we have to move, either to right or to left? Here we have to move towards right because we are doing addition 2 plus 3. So we have to move to right side. From 2, how many positions we have to move? 2 plus 3. So we have to move 3 positions towards right side. From 2, starting at 2, 3 positions to right side. So now we reached 5. That means 2 plus 3 equal to 5. So this way, using a number line, we can do additions. Let us see the subtraction on number line. Let us subtract some whole numbers using a number line. 6 minus 2. Subtraction of whole numbers on a number line. So 6 minus 2, the first digit is 6. Now go to 6 on the number line. Here we are. Minus 2. We have to move 2 positions. On which direction? To right or to left? As this is a subtraction, we have to move to the left side. If it is addition, right side. Subtraction, left side. How many positions? 2. Because it is 6 minus 2. From 6 towards left, 2 positions. So we reached 4. So 6 minus 2, 4. In this way, we can subtract whole numbers on a number line. Multiplication on number line. Say for example, 2 into 4. So how to do this multiplication of whole numbers on number line? 2 into 4. That means 2 positions 4 times. These 2 positions to the right side. How many times? 4 times. 1, 2, 3, 4. So we reached 8. So we are moving right side. Every time 2 positions. How many times? 4 times, because it is 2 into 4. So we got 8. This is the multiplication of whole numbers on number line. Properties of whole numbers. Let us see 5 plus 7 equal to 12. So here 5 is a whole number, 7 is a whole number, and even 12 is a whole number. 3 plus 4 equal to 7. This is a whole number and 4 is a whole number and even 7 is a whole number. So here what do we understand? From these examples we get that the sum of 2 whole numbers gives a whole number. So here the sum of any 2 whole numbers will be a whole number. So this is the one of the property of the whole numbers. Now let us see another number. 2 into 3, 6. 2 is a whole number, 3 is a whole number and 6 is a whole number. 4 into 5, 4 5 is 20. So here also all the 3 are whole numbers. So here the product or the multiplication of any 2 whole numbers gives rise to a whole number. So here in the previous one we have seen that the sum of any 2 whole numbers gives rise to a whole number. Even here the multiplication of any 2 whole numbers gives rise to a whole number. So what we can say from these 2 examples, we can say that the collection of whole numbers is closed under addition and multiplication. But this is not possible in subtraction and in division. Let us see, let us verify. Let us see here a subtraction. 5 minus 7. If you remove 5 minus 7. So from 5, if you remove 7, you will get minus 2. So these minus numbers are not the whole numbers. Whole numbers are the collection of natural numbers and 0. So this is not a whole number. So a whole number minus a whole number may not become a whole number. Look at the division. 5 divided by 2. It becomes 5 by 2. So this 5 by 2 is not a whole number. This is a fraction. 5 by 2. It is not a whole number. So here it doesn't apply to division and subtraction. Whereas in addition and in multiplication, we find that the sum of 2 whole numbers become a whole number and the multiplication, the product of 2 whole numbers always becomes a whole number. Now let us look at the commutative property of whole numbers. Say for example 3 plus 5 equal to 8. In the same way 5 plus 3 equal to 8. So here we have 2 examples. 3 plus 5 equal to 8 and 5 plus 3 equal to 8. So what is the difference? Here the order of this whole number pair is changed. The rest is same because the numbers are same but the order is changed. Here 3 plus 5, here 5 plus 3. But the result is same. So the sum of the whole numbers, even though the ordering pair is changed, the sum, the value will be the same. This property is known as commutative property. So the whole numbers are commutative in case of an addition. Now let us see multiplication. 2 into 3 equal to 6. 3 into 2 equal to 6. Here we have 2 whole numbers multiplied. We got a result here, product, and here the same numbers, but the order of the pair is changed. Even though the order of the pair is changed, the result is same. So the whole numbers are commutative in case of multiplication also. Commutative property of whole numbers. Let us see the addition of 2 whole numbers. 3 plus 5 equal to 8. 5 plus 3 equal to 8. So here we have an addition of 2 whole numbers, 3 plus 5. In both the cases, the whole numbers are same, but the pair order is changed. Here the same pair 3, 5, even 5, 3. The order is changed. Even though the order is changed in the addition of whole numbers, the result will be the same. So we say that this property is known as commutative property. Here we say that the addition is commutative in whole numbers. So in whole numbers, the addition is commutative. Now let us look at the multiplication. 2 into 3, 6. 3 into 2, 6. So here same value, the product is same, but here the numbers are changed. So the pair order is changed. In case of a multiplication, even though the order of the pair is changed, the result is same, it is equal. So in whole numbers, the multiplication is also commutative. Multiplication of whole numbers is commutative. Multiplication is commutative. So we can say that the addition and multiplication are commutative for whole numbers. Associativity of whole numbers. Now let us see 3 plus 4 plus 5 is equal to 3 plus 4, 7 plus 5 is equal to 12. Now the same thing by changing the arrangement. 3 plus 4 plus 5. We have written like this. So now 3 plus 4 plus 5, 9 is equal to 12. So here in this addition, the arrangement is different. In this case, in the first example, we added 3 and 4 first, then we added to 5. In the second case, first 4 and 5 we added first and added it to 3. So we got 12. In both the cases, the result is same, even though here the arrangement and the order of addition is different. So here we call this property as associative property. So in addition, the whole numbers are associative. Now let us see the associativity in multiplication. Now let us see the associativity of multiplication in whole numbers. So here we have 3 dots in 6 cells. So 3 into 2 columns, and even the pattern is here like that. So we have in every box we have 6 coins, 3 in a column. So 2 columns, 3 coins into 2 columns, 3 coins into 2, 3 into 2. So this is the pattern. So 3 to 6, 3 to 6, 3 to 6, 6 plus 6, 12 plus 6, 18. Here, if you look the same, but in a different pattern, 3 columns, each 4. So we write 4 into 3 and 4 into 3. 4 3s 12, 4 3s 12. So 24. Let us see the associativity of multiplication for whole numbers. Here we have some dots arranged in a box. So this box is having 2 columns and 3 dots in each column. 3 into 2, 3 into 2, 3 into 2, 3 into 2. And in the same, here is a different arrangement. 4 dots in each column, 3 columns, 4 into 3. So here total 4 boxes are there. Each one is having 3 into 2 into 4. In the same way here, 2 boxes, 4 into 3 into 2. 3 to 6 into 4, 24. And 4 3s 12 into 2, 24. So here in both the cases the answer is same, the value is same. But here the numbers that we are multiplying at the beginning are different. So this property is called as associative property of multiplication for whole numbers. So we find that addition and multiplication are associative over whole numbers. Now let us find this example. Find the product of 5 into 9 into 2 into 2 into 3 into 5. By applying commutative property, we change the order of these numbers. 5 into 2 into 9 into 2 into 5 into 3. So now this is that commutative property. We applied the commutative property here. So now we use that associative property. 5 into 2 into 9 into 2 into 5 into 3. So this is associative property. So this is the associative property. 5 to 10 into 9, 2 5 is 10 into 3. So 10 9s 90 into 10 3s 30. So 90 into 30 is equal to 2700. So in this way, by applying this commutative property and associative property, we could do this multiplication in a simple and easy way to directly find out the answer.